All right, guys, today's not much new. It's just an extension of what we did yesterday with segment addition, postulate, and midpoint. We're just going to work on something called a segment bisector. A segment bisector. A segment bisector is something that bisects a segment. Okay, so it will go through the midpoint. The key here is the wording. This says line PB is a segment bisector of GK. Of GK. So GK is getting split up. So that means M is the midpoint of GK. GM equals MK. Okay? GM equals MK. Definition of a bisector. So let's look here. There's a lot going on, so you have to read what's being bisected. GK is a segment bisector of PB. Of PB, so what is bisected? Correct, PB is bisected. So that means 4x plus 10 equals 7x minus 8. Definition of a bisector. Let's solve this out. 3x is 18, x is 6. It asks us to find GK. So to find GK, we need this piece and this piece. So this is 12, because it's just 2 times 6. 14 times 6, 84, minus 36. 48. So GK is equal to 60. Okay? Just make sure you're seeing what this says, what is being bisected. And it's just doing the midpoint. Okay? A segment bisector just bisects it in half. You can also have, and don't worry, all this will be in the notes, you can also have a perpendicular bisector. To be perpendicular, it just means it creates a right angle. Perpendicular creates a right angle, 90 degrees. So if these two things are perpendicular, it creates a right angle. And you would write this as EF, line EF, is perpendicular. An upside down T means perpendicular. GH. Okay? We'll use this more often later. So let's go to a problem. Okay, so we have BD, segment BD is the perpendicular bisector of segment AC. So it's perpendicular. We don't need that for anything in here. It's just getting you to understand perpendicular. And it bisects it, so that equals that. Well, let's look at how we're going to go about solving this. We have two variables, x and y. How do you solve something with an x and y? Yep, systems. Well, we need two equations. Let's set up one. If these two things are equal, I have 2x plus 9 equals 10y minus 1. And what allows me to set that up is definition of a perpendicular bisector. You have to explain everything. So if we're solving a system, I like to get my x and y to the same side. So 2x minus 10y is negative 10. We'll bring the 9 over. Now we need another equation. We had this AC is 6x plus 4y. What do I know about this segment, and the entire segment AC? Yep. The sum of the two smaller segments equal the larger by segment addition postulate. Good job. 2x plus 9 plus 10y minus 1 equals 6x plus 4y. Again, you have to explain everything you set up. Whenever you set up an equation, you have to explain it. The reason you know this is by the segment addition postulate. This is worth as many points as just setting it up. Let's bring all of our x's together. All right, so we got 2x plus 10y, and our y's plus 8 is 6x plus 4y. We're going to bring these two over here. 8 equals 4x minus 6y. So I have my two equations. I'm going to create them into a system. 4x minus 6y is 8. 2x minus 10y is negative 10. That is my system. I want to make them match. I'm going to do elimination. So I'm going to multiply this one here by a negative 2. So it becomes negative 4x plus 20y is 20. Make sure you distribute that negative 2 to each of the three terms. And the reason I picked negative 2 is because I want to eliminate the 4x's. I want to eliminate the 4x. So here I have 4x minus 6y is 8. I'll add them. That'll cancel. 14y is 28. Y is 2. So I got y is 2. I could plug this 2 into either of the two original equations. It does not matter which one I plug it into. Let's just do it right here. 8 equals 4x minus 12, right? Because I plugged in the 2. 4x is 20. X is 5. Now, let's find all the missing pieces. If x is 5, 19 for AB. If y is 2, 19 for BC. Well, they better be the same because we said that B is the midpoint, and it cuts it in half, so they must be equal. Therefore, AC, we plug it in, we got 6 times 5 is 30, plus y times 2 is 8 for 38. Whoa, look at that. 19 plus 19 is 38. It's like magic. All right, guys, I want you to go through the notes and work on this systems review, because I think you're going to need it. And I'm going to throw you 2 practice problems. 1, 2.